Hey there, awesome physics students. Let's talk about some of the various forces we're going to use in our force analysis with Newton's laws. These are less often encountered forces. Let's start with drag. Drag you've experienced, I'm sure, before if you've driven or ridden in a car and you roll down the window and you stick your arm out the window. You can feel the force of the air hitting your arm as you go through, as long as you're going more than about 30 miles an hour. And the reason that this is imagine your car looks like this. What's happening is if you have a velocity in this direction, what's happening is that the molecules in the air is made of tiny particles, when you're driving through them, they strike your car and they bounce off, right? And so when they do that and they bounce off, they put a force this way. That collision puts a force on your car, the opposite direction of the motion. So a key part of drag is that it opposes motion. And you, of course, know this by sticking your hand out the window. Drag, of course, as you've experienced in a car, you'll notice that it gets larger with higher speed. So it depends on the speed. It's important for when the speeds are high. And it's also very important in things like water. So dense fluids. It's important. Most of the problems we're going to do in this situation, in this course, are going to be in air. Most of the time you can just ignore it unless you're specifically told to include drag. So let's talk about thrust. Thrust is encountered in rockets and things things like that, like water rockets, or it could even be, you could even think of it like with your garden hose. Your garden hose experiences some thrust too, and this occurs when you have, let's say, you have a rocket like this with some fins like that. Not an artist. And what's happening is the rocket is expelling hot gases or water. If it's a water rocket, it's expelling that with high velocity out this direction. And because of that expulsion, because of conservation of momentum, the gases exert a force on a thrust force on the rocket forward. And so this varies. If the more mass that you can expel out the back, and the higher the expulsion speed of those gases or that fluid, then the bigger the value of the thrust will be. This is really important in situations with airplanes and rockets and things like that, but we don't really encounter it in other situations. Finally, let me just say something about electric and magnetic forces. I'm not even going to talk about magnetic forces, but let's just talk about electric forces. Electric forces occur when you have let's say two charged particles, let's say two positively charged particles, negatively charged particles. They're going to feel a repulsive force because like charges will repel each other. Similarly, if you have two positive charges, those two are also going to repel each other, equal and opposite. And however, if they're opposite charges, so if one's positive and one's negative, then they're going to be attractive. So this is just a force that depends on the amount of charge that's here. So more charge is more force. And it also depends on the distance. So if you get those closer, the force increases. If you get them farther apart, the force gets smaller. Okay? And magnetic forces is something we'll talk about later. I'm going to leave that.